PPAP.
Okay, students, so before we go through the task sheet, okay, I need to show you something, okay, is the concept or the process, okay, of diffusion, okay, and the topic we are going to talk about today is the active transport, okay. So for the diffusion case, okay, we just put the ball, okay, on the higher point, that means the region of higher concentration, okay, and then we release our hand, the ball will automatically fall down, okay, down the concentration gradient or along the concentration gradient, okay, in diffusion. So in this case, we are going to talk about active transport, okay. So can we, okay, push the ball, okay, from the lower part to the upper part? Of course we can, okay. So that's the concept of active transport today, okay. We can move, okay, the particles from a region of lower concentration to a region of higher concentration, okay. So that's the point of active transport, okay. In this case, we are moving the particles against the concentration gradient, okay, and also you can see that we need to input energy, okay. Okay, students, so after watching the short demonstration before, okay, so we are now going to talk about the active transport, okay. So turn to the preparatory task sheet and then turn to page 21, okay. Actually, you can find all the keywords, okay, from the text, and I'm now going to talk about the concentration gradient, okay, the triangle in your task sheet, okay. So you can just copy the concentration gradient first, okay. It's the same as the diffusion case, okay. We still have this triangle, okay. At the higher point, okay, is a region of higher concentration, and in the lower point, okay, is the region of lower concentration, okay. As we said before, in this case, okay, active transport, okay, is helping us to move some particles, okay, from the region of lower concentration to the region of higher concentration. So, okay, that means you need to draw a circle first, okay. It means the particles, the molecules, okay, but except water, because, okay, water, the net movement of water, okay, is osmosis, okay. It's not traveling, okay, along or against the concentration gradient, because water molecules, okay, they are traveling along or against the water potential gradient. So it's not the case in active transport, okay, make sure that. So for these particles, maybe glucose, okay, maybe salt, mineral salt, okay. So we want to move it from the lower concentration region to the region of higher concentration. So you need to draw an arrow, okay, up to the hill, okay. And this part, okay, you need to see that. You need to understand that. How can we describe this concept? Okay, it's against the concentration gradient, okay, up to the hill, okay. But before that, okay, you should remember, if we are talking about the concept diffusion, okay. So particles over here, and then they will travel down the concentration gradient, okay. But how can we say down, okay? We say along, okay. So in this case, okay, the difference is that against the concentration gradient is an active process. You push it, okay, from lower point to upper point, okay. But for along, you just release it, okay, and it will fall down, okay. It goes along, travels along the concentration gradient, okay. So active transport, okay, for us, okay, at this moment we are talking about this case first, okay. We are talking about this case first, okay. For against, okay, the concentration gradient, okay. Probably we all understand that, okay. There must be the use of energy, okay. So after talking about energy, okay, one thing, okay, I need to ask you is that how can our cells produce energy, okay. So the answer should be respiration, okay. respiration, okay, is used to release energy, okay, and then after that, okay, we need to think about any condition or any situation, okay, when an organism is, okay, an animal or a plant, okay, or even just a cell, okay, which factor or which condition will affect the rate of active transport, okay? So one case is that, okay, just expand the concept. Respiration, okay? What does it need? Okay? What does this reaction need? Okay? Apart from food, okay? Apart from food, it should be oxygen. 除咗嘢食，就係氧氣啦。Okay? So the point is that apart from when the cell, okay, is in a low oxygen content situation or in a high oxygen content situation, okay, the rate of active transport may be a little bit different, okay. So that's the case we need to think about first, okay.
PPAP. I have a pen. I have an apple. Apple pen. I have a pen.
Okay, students, so we are going to talk about the lower part, okay, of our task sheet, okay. So in the lower part, you can see that the cell membrane structure, okay, the phospholipid bilayer, the head, tail, head, okay, the phospholipid bilayer, and also the membrane protein. In this case, okay, we have the carrier protein, okay. So now I'm going to talk about why, okay, does the active transport need a carrier protein, okay, but not just let the substance or for example, okay, there is a substance here, okay, but why not we don't just let it or it can comes into the cell or goes out the cell, okay. So the case is that if we just let it, okay, let it go into the cell or let it go out of the cell, okay, it's totally a passive process, okay. So in this case, we are going to active, okay, that means we need something, okay, to catch it, okay, to catch it into the cell, okay, or to remove it out of the cell, okay. So that's why we need the carrier protein, okay, in our cell membrane to do the active transport, okay. And also, why not we use the channel protein? Remember, we have the channel protein, just a tunnel thing, okay. So why not? Because the channel protein is just a kind of tunnel. Okay, maybe, okay, the channel is open and then the things, okay, it will just go in or go out of the cell by themselves, okay. So that means it's still a passive process, okay. So now we are talking about active, okay. So we use carrier protein to catch it and then put into the cell, or catch it and throw it out of the cell, okay. So carrier protein in this case, okay, I would like to use an example. These blue circles, okay, are glucose, okay. Glucose is a kind of useful substance, important substance for our cell, okay, because glucose is for respiration, okay. So the point is that, okay, like blue, okay, these glucose molecules, okay, they will bind to the carrier protein, and then the carrier protein, okay, is just like a trap, okay. Once the glucose molecule bind to the carrier protein, okay, the trap will be opened, okay, and then the glucose molecules, okay, will be brought into the cell, okay, from a region of lower concentration to a region of higher concentration, okay. So that's the point, okay. And another thing I need to point out is that, okay, in this case, I use glucose as an example, and I use a carrier protein for glucose as an example, okay. So if now I have the triangle substance, okay, for example, this triangle substance is salt, okay. So, can these salt molecules, okay, go into the cell, okay, even from lower concentration to a higher concentration, okay, by using this carrier protein? Sorry, it cannot, okay, because probably the carrier protein, okay, we have a feature, okay, we call specificity. That means the carrier protein is specific. Okay, how and why? Okay, the point is that one carrier protein is specific for one particular molecules. For example, this carrier protein for glucose only, and the other carrier protein for this salt only. Okay, so the point is that don't just think, oh, we have the carrier protein and then we can bring all substance, against the concentration gradient. Okay, probably we have many types of carrier protein, to help us, to do the active transport. Okay, so that's the part for the lower part of the task sheet.